On to our fourth installment of 4.3. We're going to talk about concavity. Yeah, buddy, let's jump into it. We've learned about increasing and decreasing. We got a little something about our first derivative test. And now, boom, concavity. Here it is, the graph of a differentiable function. Wow, I can't speak. Y equals f of x is what we're going to call concave up on an open interval if its derivative is increasing on that interval. Concave down on an open interval. I know it's not the same words as concave and convex. It means two different things. This is a mathematical term. So don't get pissed off about concave down. And I know we don't call it convex. That's a different word. This is a mathematical term. All right. So concave up and concave down. And let's just write concave up. Here's concave up. It holds water. You know what I mean? That's the way I think of it. Something that's concave up will hold water. Something that's concave down, all the water will fall out. But the thing is, on some, we can graph, things will change. Wow, we got different concavities. And they're really hard to tell where things are concave up and concave down. If we break something right here and go, well, that looks like it's concave down from here to here. And maybe we break it right here and we go, well, now that's concave up. And then we break it again and say, now that's concave down. And then we say, all right, the rest of it's all concave up. So that's going to be our game as to how we talk about our concavity here. Just a little bits of some games. Now let's keep on looking at this. And here's really what we need to do. So if we want to find out where something is concave up, or our intervals for which something is concave up or concave down, we want to take a look at their second derivatives. It's all about the second derivative. So when the second derivative is greater than 0 on the interval, then we're going to say that it is concave up. And when the second derivative is less than 0 on the interval, we're going to say it's concave down. So we're going to use our same concepts as what we used before. So if we're saying that f prime was increasing, the derivative was increasing. And now we're saying, if we can just set that second derivative greater than 0, or maybe we just set it equal to 0 and we do some interval testing again, so we can find concavity. So let's take a look at a couple problems. Excuse my dogs for a moment. And we keep taking a look. And let's see what we got. I got a problem here. Oh, here we go. Let's go find the intervals of concavity for the following. So we're going to start off with this one. We just want to know, where is this thing concave up and concave down? And I've thrown some extra nonsense into this just to make it seem like this is a tough problem. It's not. This is a gimme. This is x squared. There's an x and a constant. This is a freaking parabola facing up. 17 is positive. Just know your freaking parent functions. I'll tell you, the graph looks like this. You can tell right here. It says squared, and 17 is positive. It's a parabola facing up. Let's go prove it, though. So we're going to take a derivative. We're going to take a derivative. And once we get done taking a derivative, we're going to take another derivative. So the 2 falls, we get 34x minus 3/4. Now, cool, we could find intervals of increasing and decreasing here, right? There's going to be some vertex down at the bottom where it's going to decrease for a while, then it's going to increase. But don't give a shit about that. We're trying to find concavity. Now we take ourselves, we're like, all right, let's go. Let's take another derivative. Let's go find, oops, get that a little bigger. Let's go find h double prime of x. We take a derivative and we find out it equals 34. Is 34 a positive or a negative number? It's freaking positive. It's positive. And we learned from right down here in our little test that, well, if the second derivative is greater than 0 on an interval, then the graph is concave up. Well, shit. It's not just on an interval. This is true for all values. All values. 34, it's saying that the concavity of this function is always positive. Therefore, oops, wrong thing. Therefore, h is always concave up. Shut up, puppy. So H is always concave up. All right, let's try ourselves another. Let's go find some intervals of concavity. Let's go. Let's take a look at number 2. This time, let's get real crazy with it. Let's go f of x, and we're going to just call it x cubed. Tough one, huh? So once again, let's take a derivative. Then we'll take a second derivative. So we're going to find out 3x squared, right? There we go. And now we'll take a second derivative, and we say, all right, we take this second derivative, f double prime of x is equal to 6x. Well, cool. Well, this is how we do some interval testing on this thing. Well, we want to set this thing equal to 0, just like we've done before, and we find out that x equals 0. So we can now make ourselves a number line. Remember that? Now we just want to check and look and see where is it concave up and down by looking at where is the second derivative greater than 0. So we want to take a look at f double prime of a value and f double prime of a value. And I sure as hell hope you can tell that if you plug in a negative number, it's going to be negative. If you plug in a positive number, it's going to be positive. So here we go. I'm going to plug in -1 and +1, and we find out that we have negative concavity and we have positive concavity on other sides of 0. So we can say it is concave up from 0 to infinity, and concave down from -infinity to 0. Because just think about this graph. Right, like this one won't look as clean, but that's concave down. That is, it wouldn't hold water, and as soon as it hits 0, it's going to turn around and go back up the other direction. Now this is concave up. None of that shit's holding water. But if this thing was to continue, wouldn't it be concave up? So that is the piece. So we have on the right-hand side, when we have positive values of x, we have ourselves it's concave up. And for negative values of x, we have that it's concave down. And that's just kind of the game. We use the same concepts. And now we're going to take a second derivative, not just a first derivative. We'll be coming back with some more problems in our next installment.